Hi, my name is Alfonso from Team 8, and this is our second presentation on the UV alarm. In this presentation, we will start with globalization and how our product is globally diverse. Next is standards. We will consider some industry standards that our product will comply with. Feasibility and risk to determine the viability of our project. Plan of action will tell how we will go through with implementing our product. Multidisciplinary aspects and personnel. This section breaks down the product into multiple fields while also displaying each of our members' strengths. Budget. We are sponsored by an FIU organization called CREST, and our end product and deliverables will describe the final concept in detail. 1 in 10 Floridians will be diagnosed with skin cancer at least once in their lives. In the US, there will be more than 100,000 diagnosed cases of skin cancer this year alone. Take this globally, and the number surpasses 300,000 diagnosed cases of skin cancer. Our product, the UV alarm, will monitor the user's outside activity and alert before the UV rays from the sun cause skin damage. This will help prevent the rise of skin cancer cases worldwide. We believe our product will be widely accepted outside of our local environment due to the fact that countries with the highest rates of skin cancer include Australia, Norway, and Germany. The World Trade Organization helps facilitate trade between countries by increasing transparency and by regularly monitoring trade practices. The US has a free trade agreement with Australia, and Germany is the US's largest European trading partner. Both countries have a free healthcare system, and our product might be considered to help previously diagnosed skin cancer patients from going into remission. Adhering to industry-set standards is important to the success of any product. I will now mention 2 standards we intend our product to comply with. First is standard P360, an IEEE Consumer Electronics Society standard for wearable electronics. This standard defines technical requirements and testing methods for wearable tech, such as basic security, ease of wear, and in functional areas like health, fitness, and infotainment. Our second standard is ROS 2. It is a directive by the European Union restricting the use of certain hazardous substances in electrical and electric equipment. These substances include cadmium, mercury, and lead. If the product is not ROS compliant, it cannot be sold in the European Union. Many states and other countries have followed the European Union in requiring their electronic equipment to be ROS compliant for sale and distribution in that area. My team member will now continue the presentation.
Hello class, my name is Aguilar, and today I'll be talking about feasibility analysis and risk analysis. Feasibility analysis is extremely important in any research project because it helps to determine how viable the project will actually be and if it can be done. It allows us to know whether the project itself is worth investing in. It also allows us to know whether what we are planning on doing is technologically and legally possible. When it comes to feasibility analysis, it is broken down into 7 key parts, which are shown here. The first of which is technical. Technical asks questions about technology and if the parts are available. Resource asks questions about skills that are needed to complete the project. Economic refers to the economic risk associated with the project. Schedule refers to the team's work and meeting times. Cultural refers to the impact the project has. The legal section makes sure that no laws are violated, such as patents. And last but not least, the marketing section refers to the attractiveness of the product itself. Taking these factors into account, we then give them a score. The score allows us to know the importance of each factor in correspondence to one another. Once we add up all the numbers, the final score will allow us to know if the project is feasible or not. Risk analysis is equally important when it comes to any project. During any developmental phase, the analysis of risk must be taken into account so that any risk can be eliminated or minimized before any losses occur. It also ensures that the risk of failure of our project is minimized. The risk analysis was taken into account with the 7 categories from the feasibility analysis and point out all potential risks that our group may encounter. As you can see in this fishbone diagram, some problems in schedule may include procrastination. When it comes to legal, it may deal with patents. And when it's marketing, it may be competition. Whatever the case is, we identify it and assign it to a category. We then identify the likelihood of it occurring and assign it a color. Green is low, yellow moderate, orange severe, and red catastrophic. Our group found a little over 10 risks that we may encounter. However, following these actions, here will allow us to minimize the potential failure of our project and maximize our efficiency. My colleague will now continue with the plan of action.
Hello everybody, my name is Bryan Diaz from Team 8, the UV Alarm, and today I will be going over the plan of action. In terms of scope, the team is going to design and build a wearable UV alarm that will alert the user when overexposed to ultraviolet light. The product will implement UV sensors and output LEDs in a vibration motor controlled by an Arduino-compatible microcontroller, the Adhering. The housing of the UV alarm will also be 3D printed. In terms of location, the majority of the work will be done remotely. The team will collaborate through online means such as Zoom and Slack, and will meet in small group sessions whenever possible. In terms of the period, the starting period of the project was on May of 2020 and will be completed by December of 2020. The design will be finalized by the end of July, accompanied with deliverables such as presentations and proposals. Work on the prototype will begin towards the end of summer 2020 and the start of fall 2020. The team will be ready for a final demonstration of the completed product in December of 2020. In terms of responsibilities, work will largely be divided between hardware and software components of the project. Each member will have an important role and will contribute to both aspects. Bryan and Pablo will focus on the software, Alex and Gabriel will focus on the hardware, and David will act as team leader. Looking at the work breakdown structure of the UV alarm, you'll notice that there are 4 main parts: 1 project research, 2 hardware design, 3 software design, and 4 end product testing. Looking at the Gantt chart of the project, you'll notice that the hardware and software components are concurrent, and team members will have to work together to finalize the prototype. Now, my team member Gabriel will go over multidisciplinary aspects. Thank you.
Hello class, my name is Gabriel Sierra. I will go over multidisciplinary aspects, personnel, and budget. Most often, a diverse group of different strengths is the critical factor in delivering a product from its initial state development to a working prototype. We have David Alfonso. He is pursuing an electrical engineering degree with focusing on power system and electronic design. Secondly, we have Aguilar, who's also pursuing an electrical engineering degree with biomedical design and project management. Thirdly, we have Bryan Diaz, who's also getting an electrical engineering degree with control system and embedded systems. Fourthly, we have Gabriel Sierra, myself, also pursuing an electrical engineering degree with electronic design and autonomous systems. And lastly, we have Pablo Calderin, who's also an electrical engineering degree with power system and logic design. Personnel. First, we have David Alfonso. David Alfonso actually had an internship last summer with General Electronics, where he worked on new product designs and development. He had hands-on experience with circuits and PCB design, hardware and software viability testing, and familiarization with soldering, oscilloscopes, and various lab tools. Second, we have Aguilar. Aguilar has worked on different projects, but most notably a Bluetooth smart attachment on a spear gun that could accurately and efficiently measure and identify fish underwater. Also, he has AutoCAD electrical skills, Java, Python programming, and exceptional problem solving skills. Thirdly, we have Pablo Calderin. Pablo actually had a sales associate internship during the summer in Paul Bench Roofing, where he assisted and provided profitable price quotes and established payments and credit terms to customers. He also answered incoming calls and provided details about services and schedule appointments. And thirdly, we have Gabriel Sierra, who's myself. I'm currently holding an electrical engineering position at L3 Harris Technologies, that I'm providing analytical work on the fabrication process of high-density printed circuit board designs and analyzing the equipment testing, trying to produce a better design process on the VS inside circuit boards. Also, when I'm not doing my internship, I currently hold an assistant manager job at Dollar General, where I practice leadership skills with a team up to 7 people. And lastly, we have Bryan Diaz, who is basically a jack of all trades. He's fluent in C and C++ programming. He has basic bash scripting in Unix environment. He has worked in embedded kernel development skills. He used to be a math science tutor, graphic designer, and he worked with a Vigo Black VVV device driver design and implementation, where he developed custom device drivers and loadable kernel models to interpret hardware on Vigo Bonbike, a low-power open source single-board computer. And lastly, we have the budget. Here are the 2 tables. The first table represents the phases of the project. First, we have the research phase, hardware design, software design, and testing, and the allotted hours that each of the team members have, with a total of $2,988. Each member is going to be paid at a rate of $12 per hour. And the second table represents the number of potential parts that we're going to use for our final design. It can be subject to change, but right now the total amount for that is going to be 172 with 31 cents. I'm going to give you guys now with Pablo Calderin. He's going to finish the presentation.
Hello, my name is Pablo Calderin, and I'll be discussing the end product description and other deliverables. This section is necessary to comprehend the final design and minimize the risk of encountering complications during production. Let's start by talking about the different levels that constitute our UV alarm. Level 0. Our product consists of a UV alarm that notifies users before they have been overexposed to the harmful UV radiation. The design inputs are the UV light, the user interaction, and a wall outlet. After receiving these inputs, the device determines overexposure and alerts the user due to the outputs of alarm and vibration. Now let's take a look at the level 1 diagram. Our design can be broken down into 4 major models. The battery system stores and powers the other systems. The sensor system uses the sensor to detect the UV level. The microcontroller determines the overexposure and then signals the alert system to set off the alarm and vibration. These major models can be further divided into the main components, which can be seen in the level 2 diagram. As you can see, the battery system is made up of 2 major components. The charger controller, which can take in the 120 volt AC when the device is connected to charge and regulate the current and voltage received and supply it to the lithium polymer battery. The lithium polymer battery is where the now regulated DC power will be stored and why it will become the main power supply once the device is disconnected and being used. Now let's talk about the sensor system. This system is made up of 2 major components. The sensor will take in the UV rays that the user and device are currently exposed to, and the UV detection module will then process the sensor data and output the exact UV level. Moving on to the alert system. Here we have 2 components working with the same power signal. The signal feeds power to the buzzer component to produce an audible alarm, and the vibrator motor component to produce a physical vibration. The microcontroller. Now the microcontroller has 3 major components. The power inputted from the battery system goes through the GST port, which is an onboard regulator for the main board. From there, the main board feeds the power to the next component, the VBAT pad, which is the main power distributor for the major systems we have talked about. The sensor will instantly be powered and able to send the UV level data directly to the main board, along with the user's skin sensitivity setting that is inputted through user interaction. Once the main board can determine overexposure from the settings and sensor inputted data, then it can send another electrical signal to the VBAT pad to distribute power to alert system. The other deliverables include a list of parts, design schematics, and final working prototypes that will be supplied with the final design, and they are essential for the operation and understanding. Now let's review what we have covered today. In globalization, we showed how our product will succeed into international market. The standard considerations, we listed and explained standards that would help introduce our product into the global market. In feasibility analysis, we showed that the product is obtainable. In risk analysis, we explained the possible issue we can encounter and weighed their impact on the project. In plan of action, we discussed how we distributed the tasks to meet our goals. In multidisciplinary aspects and in personnel, we talked about the different skills each team member had and how the dynamic helped with teamwork. In budget, we covered our expenses for the project. And lastly, in end product description, we talked about final design, which will minimize the risk of encountering complications during production. Thank you.